Okay, today we're going to talk about spheres for our podcast. Spheres are pretty easy for us to work with, basically because for things like surface area, there generally isn't a base. It's just the sphere, just the outer surface. And volume, again, one simple formula. We don't have to do all these complicated calculations. The only real variable we work with in a sphere is the radius of the sphere. And so we want to make sure that we're able to find the radius of the sphere. Once we have that, all our calculations are going to be basically working with just that one measurement. For the surface area of a sphere, the formula is very simple. It's 4 pi r squared. That's it. The total surface area is 4 pi r squared. So if my radius is 5, all we do is put it into our formula, 4 times pi times radius of 5 squared. Now, order of operations does remind me that I have to do this first. Okay, 5 squared goes first, so that's 4 times pi times 25. Then we can combine the 4 and 25. Gives me 100 pi, and of course our units, and it's an area, so it's centimeters squared. Very simple to find the surface area of a sphere. For the volume of a sphere, the formula is a little more complicated, but it's not too bad. The volume, again, depends only on the radius, and it's just 4/3 pi r cubed. So 4 pi r cubed over 3. In this case, radius is 5. So it's going to be 5 cubed. So again, order of operations tells me I have to do that 5 cubed first. So that's 4 times pi times 125 over 3. The 4 times 125 is 500 pi over 3. We're going to find that unless that radius is a multiple of 3 somehow, that generally this does not reduce. So we just put our units in, which is going to be centimeters cubed because it's a volume. So again, volume and surface area are very simple for a sphere. For a hemisphere, volume and surface area are also pretty simple. Well, volume is very simple. The volume is simply half the area of a sphere. That's all we do. Find the sphere surface area, divide that by 2. That's all it takes for the volume of a hemisphere. For the surface area, we do have to take some things into account. We have 2 parts for the surface area. We have what's called the dome of the sphere. We also have, for a hemisphere, a base. Now, all have the same radius. The dome is half the sphere, which would be 2 pi r squared, because the whole sphere surface area is 4 pi r squared. So that's the dome area. Plus the base area, which is just a great circle, which is going to be another pi r squared. So the total area is 3 pi r squared. Now, sometimes that base is exposed, sometimes it's not part of the surface. We'll see an example in a second where it's not. But that's the formula for the total surface area of a sphere, hemisphere, excuse me. Just 3 pi r squared. So, if my radius here happened to be, say, 6 inches, then my total surface area would be 3 times pi times 6 squared, which is 3 times pi times 36, or 108 pi inches squared. If we're working with something like a shape like this, now it gets a little more complicated because I've got a hemisphere on top of a cone. So we're going to have to work with both. We're going to have to break it down a little bit if I want the total surface area and the volume. So, a couple things we're going to have to work on. First off, the radius here of the hemisphere is also the radius of my cone. And if that's the case, then what we want to do is we want to be working with that radius in order to find all the information that we need. Please excuse the obnoxious announcement in the background. Can't help that. All right, so we're going to break it down. I've got a dome to deal with here, but not a base. So all I need is the dome area for that hemisphere. So I need the total area of the dome. Plus, I also don't have the base of the cone shape. I only have the lateral area. That's going to be my total surface area for the shape we have here. My volume is going to be found by finding the volume of the hemisphere plus the volume of the cone. So we've got a little bit of work to do here. So let's break it down one piece at a time. Finding the dome area for the hemisphere is pretty simple. That's 2 pi r squared. The radius is 6. That's 2 times pi times 36, or 72 pi. The lateral area for the cone is going to be used by finding the formula perimeter times slant height divided by 2. So I need the perimeter of this base, which is a circle, which would be 12 pi, times the slant height. Okay, we got a little work to do here. The slant height here, we're going to have to set up our Pythagorean theorem. So 6 squared plus 10 squared. Actually, I think the 10 is supposed to, well, no. 6 squared plus 10 squared equals L squared. So it's 36 plus 100, or 136 is the slant height squared. The slant height is the square root of 136. What's that? I can simplify that. That is 2 root 34. When I simplify that, so my slant height is 2 root 34. I'm going to divide that by 2, so that's 24 pi root 34 over 2, but that reduces to 12 pi root 34. Not pretty, but it gets it done. So my total area here would be 72 pi plus 12 pi root 34 centimeters squared. My volume now would be pretty simple. Find the volume of the hemisphere. Well, it's 4/3 or 4 pi r cubed over 3, and then we're going to divide that by 2. Because half a sphere. Radius is 6, that's 4 times pi times 6 cubed, which is 216, over 3. 4 times 216 is 864 pi over 3, but that does reduce to 288 pi. But when I divide that by 2, we wind up with 144 pi. The volume of the cone, you recall, is base area times height divided by 3. My base area is pi r squared, so that's 36 pi, times the height of 10 over 3, so that's 360 pi over 3, or 120 pi. Now those two terms actually combine. That gives me 264 pi. And there's my total volume. Clearly, this is an example of a very advanced level problem, one that would definitely be an extension type question on a test, but one that's doable. We just have to break it into pieces. And when we see complicated problems like this, that's always going to be the trick. Break the complicated problem into smaller problems and then solve each smaller problem individually until you can get your answer. That concludes today's podcast. Today's question of the day is, and this is what I'll be looking for in your homework to make sure that you did actually watch the podcast. What is your favorite color? Yes, it's extremely complicated. See you in class.